Hello again. Tonight we're going to talk about once again the Betelgeuse supernova. It'll happen any day now, or maybe not for hundreds of years. Prior presentations talked about what we'll see as spectators from Earth. This is going to turn it the other way around and say, if you're relatively close to Betelgeuse, how will it affect you? You meaning somebody at some distant star or an exoplanet orbiting that star. The focus, as I said, is going to be on the things near to Betelgeuse. Earth is several hundred light years away, so it's not going to, under current presumptions, affect us anytime significantly soon. We're going to talk about the other stars and star systems and exoplanets that are going to be nearby. We'll also focus on recurring novas that may be forced into existence and how they may trip early based upon the energy that they are imparted with from the Betelgeuse supernova. So, as the saying goes, it's a matter of when, not if. Yes, Betelgeuse will go supernova at some point. It's more than 640 light years away, maybe many years to come. What will happen when it goes supernova is likely a neutron star. I don't think it's going to be large enough to become a stellar mass black hole, but you never know. And I think that there's things that are keeping Betelgeuse from going boom. Once it does, it'll likely, be bright for a while and it'll shrink back down to a planetary nebula. But for the things closer, the effects may be almost immediate, and for others, it might take a long time to come. So when a supernova occurs, all the stuff coming out from it is called an expulsion. The shape of the expulsion over the years has changed. If you remember all the sci-fi movies about things detonating in space, it was always sort of donut shaped, an ellipsoid with the thing in the middle and it blowing outward, so creating kind of a donut shape. And then they found out from real evidence that no, sometimes they're actually a sphere and it goes off in all directions, not just around the equator of it. We do know the basic composition of a supernova expulsion is going to be neutrinos, radiation, plasma, which is ionized gas that's not yet ionized, debris, rocks and such, mostly from the planets that have been shattered, and how big and dense those fields will be. When it occurs, it'll likely be expanding over a distance of light years over some amount of time. Anything that's close in will get a good portion of that rather quickly. Anything that's further out will take longer. If the thing that's longer in transfer time is light objects like neutrinos, those will actually arrive at roughly the speed of light. Gravity waves are just a touch slower. They'll arrive a little slower than that. And then you'll start to get the radiative effects, the electromagnetic spectrum stuff, gamma, X-ray, UV, visible, infrared, radio. And then the things that are more substantive, like plasmas and gases, those will lag behind a little bit. So you'll get those. And then finally, you get the junk, the dust, the rocks, any loosened asteroids and comets from whatever shattered that solar system around Betelgeuse. The actual duration of all this stuff, even if you receive some of it within a few light years because you're close to it, the slower moving stuff might take decades to catch up with you. And that may be your demise is, hey, we beat out the electromagnetic radiation, then you get clobbered by an asteroid or comet. And one of the things that I think is keeping Betelgeuse from going supernova is Sawarha, which is they discovered another little red star that's actually orbiting Betelgeuse so close that it's actually orbiting within the expansion field, the plasma of Betelgeuse. And so if you have a red star that is in orbit about something gathering plasma on the outside of it, that will periodically detonate because the plasma is ionized hydrogen mostly. So it'll form a shell on the outside of the beetle buddy, and then that will build up until it reaches a limit, and then it will detonate, and that's a recurring nova. So if there is a small recurring nova that's actually hiding within Betelgeuse, that could explain the sudden light bursts that we periodically see from Betelgeuse, followed by the darkness. Is it blew off a chunk of Betelgeuse that's now gone, or some of it gravitationally fell back, and now it's going to build up for another pulse. And as you diminish more and more of that, it takes longer and longer for Betelgeuse to restabilize and get closer to its supernova. So we may find that it's not going to happen for much longer than we think, because Beetle Buddy keeps acting as the release valve. But once it does go nova, it'll either be blasted by the expulsion field, or it'll be kicked out of the Betelgeuse solar system and become a rogue red star. We'll see someday in reality. So I took a list of the things that were within roughly 50 light years of Betelgeuse, also known as Alpha Orionis. And what would the effect be? Well, in the right column, you can see the distance in light years. So HIP 27648, HIP is a Hipparcos catalog ID number. You can look those up in Stellarium or your favorite telescope mount. And if you are looking for something that you might actually be able to see naked eye, look at HIP 27386. It's magnitude 5.26, which is naked eye visible from Earth, and it's 44.2 light years from Betelgeuse. So when Betelgeuse goes boom, then 5 light years out is going to be something that, to our knowledge, has no exoplanets, but then we don't know about all the exoplanets. We only know about the bigger ones, the brighter ones. But anything within this range of less than about 50 light years is probably going to, if it's an exoplanet, it's going to have an atmosphere stripped, because if its rotational speed is like 24 hours a day or something in that ballpark, then the radiation field and the pressure is going to last longer than the rotation period of that planet. And so it's just going to strip the entire atmosphere off the planet, and you'll have just a rock. If it heats it up enough, you'll actually take the surface of that rock and make it molten once again. So these are the deep danger zone items. Consider that even when supernova occurs, the fastest things are going to be at light speed. So it could take several Earth years for the effect to hit these exoplanets around these stars. But the closest one is 27386. So I zoomed in on that one, looked it up, got all the identifiers for it. So if your particular software or telescope mount doesn't have the Hipparcos catalog, it might have the HD or the Henry Draper catalog 38710, or the Smithsonian Observatory 113150. Or if you just want to punch in the coordinates, there's the Aryan-Dec. That's the J2000 Aryan-Dec. This particular star is actually a binary, but it's a yellow-white binary. It's not like a red dwarf binary that's going to have a recurring nova. It's a yellow-white binary. So when the supernova goes flooding through, it may actually, make the smaller binary either change its orbit or be ejected as a rogue. And down at the bottom there visually, if you see in the upper portion, you see where Betelgeuse is, and then you see a little red rectangle, and that's where 52 Orionis is located. But it's naked eye visible right now. So when Betelgeuse goes off, pay attention. That may suddenly go away within 40 years, because it'll take some time for it to get there. So this is things that are greater than 50 light years away, but less than 75 light years away. I just picked 75. Otherwise, I'll have hundreds of stars to munge through. These might not have an extinction level event, but they might have enough radiation and debris going through that it might affect a portion of an exoplanet. So it might strip some of the atmosphere off, or the smaller moons of that solar system might lose their atmosphere, but the larger terrestrial planets like a Earth or a Venus or a Mars might not lose their atmosphere. But the plasma flying through probably is going to make a good aurora if you have a magnetic field or a large temperature swing. So I picked one, and it's Nu, not NU, but Greek NU, Nu Ori. It's a binary star system. Once again, that's the most prevalent type. And its magnitude 4.42. It's 72 light years away. So even after Betelgeuse, from our perspective, goes supernova, we may not see an effect on this star for another 72 years. And then all of a sudden, it flares up or disappears, or we see that the binary is no longer a binary. What about the exoplanets? Well, any exoplanets that are at less than 20 astronomical units, and an astronomical unit is the distance from the Earth to the Sun, about 92 million miles, and that's Earth units. Anything that's about 20 AU or closer, as Betelgeuse is expanding, it's probably likely already consumed in the plasma field those exoplanets. We don't know of any other exoplanets in that region because Betelgeuse is fairly bright. It's hard to see it. The closest exoplanet by linear distance from Betelgeuse is something in the constellation Chameleon, and it's CT Chameleon. CT is the identifier for the star within the Chameleon constellation, and then the lowercase b is the first exoplanet we discovered in that star system. It's large. It's about 17 Jupiter masses, so it's relatively big. We don't know a lot about it, but we know roughly where it is and that it's orbiting this particular star. But given that it's that far away, it's about 850 years, light years away from Betelgeuse, it may take longer for the effect on this particular star and exoplanet than it would to affect the Earth. Given dispersion, the effect will be even less, but that's the closest exoplanet I could find to Betelgeuse that's on record. And then cascade effects. Everybody's so eager to talk about the Kessler syndrome of if something produces the correct amount of recurring debris in the Earth's orbit from satellites colliding in debris, hitting debris, hitting debris. Cascade effects can be from other reasons. So when Betelgeuse goes bang, a number of things, the plasma, the comets, the asteroids, the chunks of things, the debris field, it might take many years at light speed for things to reach other things. So the debris field will be spreading out. Initially, all of the electromagnetic stuff, and then the physical stuff, and then the actual heavy junk. So it could take hundreds of years for it to affect things. We may see that stars get pushed together that are binaries, and we might monitor the gravitational wave effects from that, the radiation spikes. And if you have, let's say, a red giant, and you have a little white dwarf, and it's orbiting it like a recurring nova would be, then the debris flowing through may actually make the shell around the white dwarf thicker, faster, and trigger a secondary or recurring nova at a time other than its normal cycle time. So look for things to be affected, binaries to change orbits, maybe becoming rogues with their own follow effects. And like I said, you may get a nova that triggers early, or you take one that isn't recurrent, and suddenly it is. Or you may have one that's on the edge, and with the extra plasma, it strips it, or it adds to it and triggers a supernova. So in summary, when Betelgeuse goes supernova, we think we're going to be safe on the Earth for maybe about 600 plus years. Betelgeuse's little buddy is probably going to take the brunt of it because it's in the plasma field already. Any exoplanets close to Betelgeuse are likely already consumed because Betelgeuse has been expanded. The nearest stars are probably going to undergo extinction level events. They're probably going to lose their atmosphere and get dispersed. And if they're that close, maybe if the supernova occurs, we can see what might happen to naked eye visible stars that are that close. But the farthest out ones, it'll take a little longer for them to show up with any visual changes. But there's at least one of those that are naked eye visible currently. So we have something to look forward to over years to come. As far as we know right now, there are no exoplanets in direct danger, but the cascade effect could occur as the expulsion field grows over 1,000 plus years. So when Betelgeuse goes bang, there's more things that we should be watching than just Betelgeuse, and some of them are naked eye, as is Betelgeuse itself, at least for a moment. And then if you didn't know, some links. Comments, questions?
Are the scientists prepared to study this thing?
I think that they know it's going to happen. They know they can turn too quickly. They kind of have a feel for what they're going to look at. I think they're missing out on the what's going to happen to all the other stuff in the area. And I don't think they're giving enough credit to Betelgeuse's little buddy for stabilizing Betelgeuse from going supernova already.
I wonder if it'll give any warning, to so that we could all mobilize and get our sensing devices aimed
Well,
at it.
they've already stated that Betelgeuse's brightness has changed over time, and Betelgeuse is a variable star. I mean, it's a red supergiant, but it's also a variable star. So its brightness goes through cycles over time. And if on one cycle where it's supposed to be brighter, it's not as bright, they look for reasons why that might be the case. And somebody said maybe Betelgeuse burped out a chunk. And so it kind of
Partial.
dimmed things down. But as that blob of cooler plasma orbits Betelgeuse, the normal bright dim cycle may be affected by it. And I think that that was before they discovered that Betelgeuse had a little buddy, and the fact that the little buddy is inside the plasma field of Betelgeuse. And so I don't think they're giving it enough credit. But the actual trigger, I have email connections that I listen to 24/7 for neutrinos.
Okay.
And neutrinos are going to arrive at Earth about 24 or a little less hours before the rest of it does. So if I see all of a sudden the neutrino detectors in the Antarctic and in Japan, and maybe the ones in Mexico, all of a sudden are going off saying, hey, we detected a giant flux of neutrinos coming from the direction of Orion, because the neutrino detection fields aren't all that narrow field. They catch a wide field. So if a burst of neutrinos comes from the direction of Orion, that's going to get my attention. I will start the clock. I already have a BA presentation, YouTube presentation on that's the timer. If you see the neutrinos coming from the direction of Orion, you've got less than a day to plan a public observing event to watch the brightening of Betelgeuse go from a relatively dim red star, still bright enough to be naked eye, but it's red, very dark red. All of a sudden, it's going to become very bright white, bright enough that you can probably see it in the daytime for a few days, and then it will dim back down. It'll be so bright at night that it'll be as bright as the full moon.
Wow.
So, yeah, watch for the neutrinos. When the neutrinos start coming in from Orion, start the less than 1 day clock. Contact all your government friends, all your parks and whatever, for getting the scopes out there and watch the skies for maybe a 48-hour period, just in case things are off a little bit. But you're going to have to continually watch. Now, when would you stage the public observing event? Shoot for 23 hours after the neutrinos arrive and make it a 2-hour event. Think of it as if you actually catch it and it goes from dim red to bright as the full moon, you can tell your grandkids because it's not going to happen ever again. But if you miss it, if you go, oh, it takes us 3 months to do a PR campaign and get the right licensing, and you're going to miss it. Any other comments or questions before I stop recording? Okay, hearing nothing.